Hi, I'm Rukan, and in this video I will be talking about Kepler's third law. Johannes Kepler is a German mathematician. He proposed the three laws of planetary motion in the early 1600s. His third law of planetary motion, also known as harmonic law, was enunciated in 1619. This is the definition from Wikipedia. The ratio of the square of an object's orbital period with the cube of the semi-major axis of its orbit is the same for all objects orbiting the same primary. It sounds really confusing, isn't it? So it basically says Kepler found that there's an interesting relationship between the average distance of a planet from the Sun, r, and its orbital periods, t. The square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of the orbit. And to make it a formula, the square of the period is equal to 4 times pi squared times a distance cubed over g times mass of the Sun. In this slide, I will demonstrate how we can derive this formula from knowledge we learned from the last unit. We all know that in the solar system, planets orbit around the Sun in an elliptical orbit, stated in Kepler's first law, but we can still use the circular motion formula in this. The only force that makes the planet stay in its orbit is the gravitational force between the Sun and the planet, and it is equal to the centripetal force. Therefore, we have Fc equal Fg. After expanding them, rearranging them, and simplifying, we will get V squared equal Gm over T. Then we will substitute 2 pi r over T into V, rearranging the formula again, and we will get equation T squared equal 4 pi squared r cubed over Gm. This is very cool. Finally, here's a simulation demonstrating the relationship between the distance of the planets from the Sun and their orbital period. It is clear that planets further from the Sun takes more time to complete a period and have a smaller velocity. For example, the orbital period of Mars is greater than the Sun, greater than the Earth, and has a smaller velocity. In contrast, Mercury, which is the closest planet to the Sun, has the smallest orbital period and moves the fastest. Thanks for watching.